So today our talk is going to focus on the goals and techniques of text mining, and then we'll demonstrate these goals, techniques with two case studies. The majority of data out there is in the unstructured format. Text mining provides valuable insights derived from unstructured data. The unstructured data allows one to understand consumer responses and turn them into actionable insights. Once the insights are discovered, we need to adapt the business actions to meet the consumer need. The techniques for text mining include natural language processing, extracting features of interest from free text documents, graphical representation of the findings, and a summarization of the results for the client. So there are several steps in text mining, and in all data mining steps, the first and most tedious step is data cleansing. So here we're removing misspelled words, things like that. And after we've cleaned the data up, we use unsupervised learning. And this unsupervised learning provides an accurate structure and findings about the documents. And after reviewing the results of the unsupervised learning, the analyst, along with the subject matter expert, further refines these results to form something that's more business-centric. And then another step we use is once we've applied the supervised learning, then we enrich the data by bringing in and blending and mashing up many different business sources or business data that's relative to the findings. And then we display it in either graphical reports. We include these new features that we've uncovered from the taxonomy of the text mining and put those into other statistical analysis. And then we also have OLAP cubes for people to further analyze. So language detection is one of the first things we do with the text mining, and we can automatically detect the language of different documents. For example, in the case studies I'm going to show today, the majority of the comments were in English, but we did have some French and some Spanish comments also. Then obviously we invoke a spell checker, and we can detect and correct misspelled words and train the algorithm to recognize the spelling of a unique internal word. The science behind the analysis involves three types of analysis. The first one is linguistics. So the data is much more than just a collection of words. The algorithms recognize the relationship and meaning of the words. So for example, in this sentence, it splits it out into the part of speech and parses it out into phrases. And then after that, we do a syntactic analysis so we can really understand what the relationship between these words are in their true usage. The next step we do is a semantic analysis, and the best example of this I got from Sergey is if I just mention the words yellow bus, in your mind you're picturing probably a school bus, but I didn't say school bus. You're probably assuming it's got four wheels, it carries people all around. And that's what our human experience has taught us. We learned all that stuff, but the computer obviously hasn't done that. So we need to train the computer to understand those associations. So here's an example. So we have cable, and there's synonyms for that, like wire would be found as another synonym. And then there's hyponyms, like power cable or network cable, that get more specific in regard to the word cable. So that's the semantic processing. And then there's finally the stats processing. Here we're leveraging the analysis of statistics. Here is, for example, a keyword table, and you can see these are sorted actually by significance, how important they are to the documents in this corpus. And if I click on one of them, cash drawer, you can see that this was used in 58 of the documents. It was actually used multiple times, so 118 total total usages, and its importance, significance to all the documents is about 38%. So that's something we're able to do quickly. And then you can drill down into this to look at how that cache drawer was used in sentences and what context it was used. Okay, so how do we do the analysis? So the unsupervised really lets the data reveal its secrets. The most important words, phrases, et cetera, are revealed, and then a hierarchical structure, which is called a taxonomy, is also generated from this analysis. And one output that we've all seen is a word cloud, and this is a typical word cloud. You can drill on this, and this one is the size corresponds to the number of citations, and then the color is corresponding to the significance or how important these are in the documents. And then we also can do a link terms analysis, which is showing the relationship and the usage between terms or concepts that we find in the documents. And then we also look at, these are phrases in, this is sentiment. So in the sentiment here, we also are grading everything based on sentiment. Here you can see overwhelmingly food is reviewed positively and negatively quite a few times less. So we also score everything for sentiment in both positive and negative. And then supervised learning. Here's where we engage the analysts and the subject matter experts to really refine this unsupervised taxonomy and all these findings we found and make the adjustments so that it makes sense in the business. So we would tweak the taxonomy here and enrich it with other data and make other relationships that the unsupervised algorithms could not quite get. And so I mentioned the word taxonomy, and a taxonomy is a hierarchical collection of categories for document coding. And the categories are defined by queries, capturing the features of interest in the text, and then we can score all of our data set with these taxonomy categories for later analysis. And the first exposure you've probably had to a taxonomy was in biology in grade school or junior high, where you looked at classifying animals or life actually into different categories. So that's kind of what we're doing with the text mining also. So here's a taxonomy. This is from one of our examples. And on the left here, you can see the categories that we have. And then in the center box, you can see the queries, the macros that were generated by the unsupervised learning to put those items into their correct categories. And we can tweak that and modify that any way we'd like to make it more accurate. And then here's an example where we're looking at kitchen monitor not showing, and that's the macro that was creating that sentence. And then if we want to drill into that, you can see several examples of this, how it was used in context and where that came up with. And you can always go back and adjust that if that's not accurate. And the tool I'm using in this talk and presentation is Megaputer PolyAnalyst. And it has advanced text analytics capabilities. It can integrate structured and unstructured data very easily. It's got some great visual tools. It's a very convenient tool, and you can generate custom graphs or web reports for your clients internally. And I've been using this software package for about 17 years, so I'm pretty committed to it. Okay, now we'll put it in the context of a couple case studies. The first case study is voice of customer data. And in this case, we're looking at over 2.5 million responses collected from a voice of customer website that consisted of both structured and unstructured data from about a 2-year period. And the structured data field consists of things like overall satisfaction, recommend a friend, et cetera, and the kind of metrics that you would use in a restaurant to categorize that experience. And then the unstructured data consisted of responses from an open-ended comment field. And then the one thing I should caveat is the customers were directed to this website on the back of a receipt, and they're given the option of filling this out, and there's a chance that they might win a prize for filling it out. So to the extent that that colors their responses, I can't control for that right now, but that probably does inflate some of these numbers. So we used 1 year of historical data outside of this 2-year period to build and train the algorithms for this taxonomy. And then we had broad categories that aligned with the KPIs of our business in the structured data, and then we refined that also into more specific categories. And then all the data was scored with these 2 categories once we got the data analysis done. And then we also passed this through a sentiment engine for sentiment ranking. So these are the broad categories that we found in the study. And these don't add up because a person's comment could involve service or a product, facilities all in one comment. So there's multiple categories a comment could be placed into based on the type of words and phrases that were detected in it. But you can see here, majority of the comments were in the service broad category. And so if we look at the overall satisfaction ratings for people that, when they rated service, the overall satisfaction rating, again, this is a top box rating, was 83% satisfied, which is pretty high. And then if we look at the overall sentiment for service, the majority of it is positive, 88% positive. And at any of these points, we could click into the data and drill and create subsets, et cetera. So if we look at the specific issues regarding service that were rated positively in sentiment, friendly, fast, great service, correct order were the highest scoring things. Those were the most frequently cited things. And then if we look at the key words that were in this positive sentiment service category, these are some of the key words here. Timely manner. Yep, sure. Yep. Right. Friendly versus good attitude. Right. How do you differentiate that? I sort of see. Well, yeah, that was just derived of the fine categories. We could certainly combine those, but we left them the way that it found it. But yeah, you could certainly, you have the flexibility of combining those if you'd like, but we kept them the way they were, because there might be a different message along with that in the context of how they were used. So this is the keyword, the top keywords for the positive sentiment service items. And timely manner, fast, et cetera, are really the positive things, and those are the things with the highest significance. And actually, if you look at friendly was the most common word used here. And then now if you look at the overall satisfaction ratings for that positive sentiment service component, now the service jumped from a baseline of 83 up to 91% if their sentiment was positive in their comments. So it's a big lift. It's a pretty good sized lift. Now we'll look at the flip side of it. So now we're looking at the negative sentiment service issues. And here, kind of the opposite of what we saw in positive: slow, wrong order, poor service, not friendly. Not terribly surprising. And the key words that we saw in here, the highest significance was slow, all related to slow or wrong item. Yep.
What are the numbers on top of the 1.4?
Oh, okay. So yeah, I should explain that. So significance means how important that word is to all the documents, and comparatively to all the documents in the English language. So these were rated as very important in this document and more important in these documents than they were in the rest of English language. So then frequency is the number of documents that, it's the total number of occurrences of that word. And again, it can occur multiple times in the same document. And then support is the number of documents, the number of unique documents where that phrase or word occurred. And then you can drill into these as you wish.
The numbers on top just indicate whether it's an integer number or not.
Yeah, yeah, it's just a shorthand for that. Okay, and now if we look at the sentiment ratings for people that had a negative sentiment, or the comments had negative sentiment, the satisfaction dropped from 83 down to 20, which is pretty low. But fortunately, there aren't very many of these either. That's the good thing. So if you just kind of look at this, what's the most important feature to focus on? If you look at this graph on the left, you saw the overall satisfaction of all the comments was 83%. The positive sentiment comments were about 91%, and the positive sentiment things that drove that were fast, quick, friendly service. And the negative, on the other hand, dropped it down at about 20%. And the most important comments and themes from that were slow service and rude staff. And so you get about a 70% drop in overall satisfaction just from going negative on these comments. Another way to look at that is this helps you understand what is really important to focus on. So this chart represents on the y-axis the percent satisfaction, and on the bubble size is driven by the number of comments. So you can see slow staff and rude staff or slow service and rude staff are big, and they have large numbers. So we would focus on those rather than, say, trash in the parking lot that only had 56,000 of 2 million comments, or products priced differently, which would be due to different stores have different prices potentially based on their market. So we would focus on the friendly staff. And with this, we can further drill into these, make subsets, understand why these are behaving the way they are. And then we also can overlay many other business type data. So since we have the receipt, that's where these people contacted, we have the receipt number, we can tell what products they ordered, what day of the week, what hour of the day. I can tell who was on shift, what kind of training they had in that store, what kind of products they bought. All those other dimensions we can add into this to figure out why this is happening. So this gives a clear prioritization of what's important, and it shows you the magnitude of customer satisfaction and provides a clear insight as to what to focus on. Okay, the second case study is a little bit different. Again, this is a service desk, but here the clients are Taco Bell restaurants. So Taco Bell has about 6,500, 7,000, or 7,000 restaurants. And each of those restaurants has a lot of complicated electronics. They've got POS systems, cash registers, timers for speed of service, broadband. You've got a computer system that keeps track of labor and all this other stuff. You've got routers, lots and lots of things, moving pieces that are all electronic. And when these things don't work, the restaurants call into the headquarters where there's a service desk, and these people answer the troubleshoot what it is, and it's not simply a matter of reboot your machine. It's a very detailed problem and very hard to fix. So what I was tasked with doing is figuring out what was going on with this help desk, and this software was amazing for this, as you'll see. So this service desk gets about 800 to 1,200 unique calls a day, which is quite a bit. It's open 24/7, and lots of calls, and some of them can take a lot of time. Some of them are fixed quickly, but most of them, take 10 to 15 minutes to solve them. And then this is important for a store, especially if they lose their cash register. Imagine losing your cash register at lunchtime. At that time, you're taking in the majority of the money. So if you're down for an hour, you might lose a couple $1,000. So there's a lot of incentive to get this up and running and resolved very, very quickly, or they may not be able to take credit cards, for example. So this is a very critical thing to fix. And here we had, I should back up. So we had, like most service desks, the analyst was presented with a computer screen that had 4 or 5 levels of categories they could categorize the call on, whether on the phone. And then there's several places, 3 places actually, where they could put open-ended comments. And I don't know if you've ever worked with call center data where you have categories. A lot of times those categories start out with 5 or 6 and they explode to many, many more categories because of mistyping and misunderstanding. So it's a nightmare to really figure out what was going on if you just looked at that categorical data. So we really analyzed the open-end comments. So we had an issue that really drove this project. We released a software patch to the stores that caused an enormous spike in the average speed of answer. And because this is a franchise-owned business, about 90% of the stores are franchise-owned, they don't like to be on hold for very long. So our target was 1 minute to be average speed of answer, and it spiked up to 15 minutes and stayed there for a while. So this was an urgent call to action we got to fix something here. So we deployed this solution, and we were able to drop the average speed of answer back down to where we were. And I'll show you in a minute, but it was just, it's not simply a matter of call volume decreasing. The calls, actually, we got more calls during this time frame, and we were able to answer it more quickly because of this solution. So the previous, the legacy analysis used, they recorded all the responses in a database called Remedy. You guys are probably familiar with it. That's where all the data was stored. We also had phone logs in a Cisco database, but these were not joined together. And then we had a lot of other business metrics that were out there about the stores, the training level, the sales volume, the type of specific hardware they had, because we had about 30 different hardware combinations you could have out in the stores. And so some of them worked better than others. And so we had all that information that we could mash together for this. And then we had 3 open-ended comments, which we were able to concatenate into one and really look at what was going on here. And I'll show you what we did. So based on the taxonomy that we were able to create from this project, we were able to very quickly deploy a tree map. And this was something that was refreshed twice a day from the live data, rolling 90 days of data. And everyone had access to this chart. You could drill on it, click on it, and see what was going on, see what was happening via a web report. So the way this works is the majority of these calls were on point of sale. So that's this quadrant here. And then the darker, so the larger size, so the point of sale thing had powered off for some reason. And then the more red the square, the more time it took to answer that call, to handle the call. So there's a red box right in here and one up in here. But you could click on those and figure out what's going on with those stores very easily. And this is all, again, based on the taxonomy, the broad and specific components of the taxonomy, and then the underlying structured data that it was associated with it. Here's another thing that was useful. Again, this is interactive also. This is just a heat map of when during the day and when during the week did most of the calls arise. And Taco Bell starts its week on Wednesday, curiously. And so they close out the books on Tuesday for each of these stores. And when they have difficulty closing out the files in the stores, that's when they got all the calls the next morning on Wednesday. So that was very enlightening for us. And then this helped us also deploy labor more appropriately. We could find these hot spots of when the calls were really happening, and then deploy more labor there and less labor where it was lower in volume. And this was a very useful chart for us. So this is a trend chart based on the major issues that were uncovered uncovered using the taxonomy, and then the total call time in minutes. And what was interesting in this, we didn't have categories for the menu keys, which is what this is, and mobile issues. They had no idea that they had a mobile issue going on in the field because they were getting so many calls, but it was buried in the text in these open-ended fields that once we saw this, like, oh my God, there is something going on. So we could click through and figure out what it was, but we didn't have those in the hard-coded categories that the analysts would choose on their drop-down menu. So that was very enlightening. Here's a link analysis chart based on the taxonomy, and the blue squares the blue circles are the broad category, and the red ones are the specific category within that taxonomy. And you can click on these and drill on them to your heart's content. And here's an example of drilling into one. Okay, and this is another link chart, and this one we happen to split it by weekends versus weekdays. And this was important because we had very different issues that happened on the weekends versus the weekdays. And then we were starting like, well, why is that? Well, in the stores, if you're higher in seniority or higher in level, you generally want the weekend off. So during the weekends, there isn't that senior level of supervision in the store that could probably solve these issues without calling the help desk. Whereas up here, these are more complicated things that occurred when a manager of the store was there, but they couldn't troubleshoot it themselves, so they had to call the help desk to troubleshoot what was going on. So that was a big aha for us. And similarly, here's a spider chart that you can drill on, and you can see the length of call, the average deviation of the length of call on weekend versus weekday is highlighted by several issues here. And you can see the database not in sync, the database user ID not there. These are all things that could be handled simply with the manager on staff, but on the weekends, he's probably not there when this occurs. And we could also look at our analyst performance on the service desk to see who's performing at a high level and who's not, who needs more training. So going back to this chart, as I alluded to before, when we implemented this solution, we got a very rapid decline in average speed of answer, and that was despite an increased call volume. So that's really remarkable that we were able to handle a lot more calls and handle them a lot more efficiently due to what we were getting out of this analysis. So the new metric reports became a part of the service desk standard operating procedure. We created web reports for the analysts and the managers in the service desk. They could see this stuff. It was refreshed twice a day. They could click on it and drill on it and understand issues in more depth than what they could with their legacy system. It identified emerging issues very quickly, and we could address them very fast. And the executive leadership had visibility now to the store issues and service levels, which resulted in an increased confidence in the service desk. And that's it.